All right, so this lesson is about regression. And so we look at three different types of regression for Algebra 1, one being linear, one being quadratic, and the other being exponential. For linear data, it's going to be close to a line. It's not going to be perfect, but it's going to look somewhat like a line. For a quadratic, you're going to have a U shape called a parabola. And for exponential, it's either going to be growth or decay. And so when we're doing regression, we're trying to get the best fit curve for the data. And usually on the STAR test, they will tell you whether to use linear, quadratic, or exponential. If they say linear, you're going to go to Desmos and use the table, add the table into Desmos, and you're going to type y1 tilde mx1 plus b. For quadratic, you're going to do y1 tilde ax1 squared plus bx1 plus c. And then for exponential, y1 tilde a times b to the x1. So the important thing to note is you have to have these ones in the subscript for your variables. That's how you refer to the table. The other thing is you have to use the tilde symbol. And so in the video, I will show you how to get to the tilde. And so I'm going to split my screen with Desmos, choose assessment, make sure you're choosing Texas Star so that you know you're using the correct Desmos. And then starting with these examples, table 1 says linear. And so we are going to put that table into Desmos by clicking the plus sign and then enter in the inputs into the X1. So 0, 1, 2, 3, 4, and then type the Y's. 3.12, 4.52, 5.92, 7.32, and 8.72. After your table is in Desmos, you're going to type y1, and since this is linear, we're going to type the linear equation. So y1 tilde m x1 plus b. And you'll have to memorize these tilde equations because they're not on your formula chart. So if you scroll down to parameters, they're saying m is 1.4 and b is 3.12. And so that means my equation is y equals m, which is 1.4, x plus b, which is 3.12. Okay, for table 2, it says exponential. So we're going to put in the table again. I'm just going to edit the one I already have. And nobody can help you with this on the actual STAR test, so it's going to be up to you to troubleshoot any issues, to remember how to add the table, to remember these equations, and so that's why we're practicing so much. Okay, double check, make sure your data is entered correctly. You're not missing any decimals. And then it says exponential, and so we're going to use the exponential equation, y1. And the reason why the 1's there is because if you look at the table, it says x1, y1. So that's how we refer to it. If it said x2, y2, I'd be typing 2's there instead of the 1. Tilde a times b exponent x1. And it says my a value is about 18.77. And my b value is about 2.12. So I like to put it in parentheses. You don't have to have the parentheses. You would just have to put a times dot right there. All right, and then this third one is a quadratic. So I'm going to get rid of that and then enter the data for this last table. Okay, and so since it says quadratic, I'm going to use the quadratic equation. So y1 tilde a x 1 squared, don't forget that, plus b x1 plus c. And then my parameters are 2, 0, and 1 for the a, b, and c. So that means my equation is y equals 2x squared. And they don't write the 0x, so we're just going to skip the x term and then put the c. So y equals 2x squared plus 1. So use this method to fill in the equations for tables 4, 5, and 6, and then check your equations with the answer key. Table 4 is quadratic, table 5 is exponential, and then table 6 is linear. So make sure you're using the correct equation for each one. And then these are the star questions. And so the only one I need to talk about is number 19. And so I'm going to skip to this last question, number 19. And so whenever you're doing regression, you have to enter every single data point. And so for this table, there's a lot. You got to type all of them. So the top row is usually your x's. Usually, it will always be your x's, and the bottom row will be your y's. So I'm going to add a table, and I'm going to type the top row into the x column. And so every single one of them, 41, 70, 21, 34, 10, 92, 54, 24, 10, 35, 42, 66. Okay, and then for the y's, 21, 25, 32, 12, 16, 45, okay, I messed something up because I don't have the same amount. So 41, 70, 21, 34, 10. I skipped 92. 92 goes with 45, and then 54 goes with the 40. Twenty-four goes with 23, 10 goes with 45, 35. All right, so just be careful. You should have the same amount of x's as y's. And if you skipped a point, make sure everything lines up. Each x goes with the right y. So it looks like I skipped the 92, 45, so I just put it at the bottom. The order doesn't matter, you just have to have all of them. All right, and so the question here says, what is the correlation coefficient for the data indicate about the strength of the association between the height and the length of these rectangles? And so whenever they're talking about correlation coefficient, they're talking about linear data. So it's automatically going to be the linear model. And I use M. You can use A if you want to, x1 plus b, mx plus b. And then they want what's called the R value. Correlation coefficient refers to the R value. And so when I type in the y1 tilde m x1 plus b, you don't care about the m and the b, you care about the R value, which in this case is 0.1555. Okay, and so when you're looking at that R value, you can kind of just focus on this number right here, the two numbers after the decimal point. And so if that number is bigger than 70, treat it like a test score. If it's bigger than 70, it's strong. If it's less than 70, it's weak. It's like failing a test. And so if you see like anything below a 70, it's weak. If you see anything above a 70, it's strong. You don't care if it's positive or negative. And so this is a positive R value. Sometimes you'll see a negative, but not for this one. So we're going to choose positive. And because it's a 15, that would be a very weak performance on a test. So this is weak positive. And so the rest of them, you'll be able to write the equation just like I did in the examples above. And then once you do these examples, check and make sure you got the answers right.